All right, so this is section 1.4, inverse algebraic properties of matrices for linear algebra. Okay, so I was actually playing around with some of the rules just to make sure that I'm comfortable with them. They're relatively, straightforward. It's just, maybe still take a look at it just to make sure that, that if they throw you terms like in question 1A, B, C, maybe you're not exactly sure, but you have a pretty good idea as to what they're talking about, right? So they're never going to be asking you, okay, for these standard equations, give me the term to describe the whatever theorem that you're supposed to know. Well, no, they're not going to do that, but if they say the left distribution law, then you should probably know something about it, right? Okay, so it's some kind of association, so let's say, I don't know, D plus E, for example, right? And it's it's the left distributive law, so something to do with factoring like, right? So I want to put either A here or B there or whatever, so that they multiply, so it feels like you're like, inverse of factoring, right? So if that, not inverse, the reverse process of factoring, and if that's so, and then once you have that all figured out, then you could say, well, if it's left distributive law, then maybe that factor should be on the left side, and if it isn't, then it should be on the right side, and so forth, right? So try to juggle through it, but juggle through the theorems so that you're sort of, on top of things. But I won't really get too much into it. You're just really proving it with some examples, right? So, and actually you don't even have to come up with examples because they give you A, B, and C. I've actually talked with some other person in the class, but just to be clear, A and these two A, sometimes they don't use it correctly, but big capital just means matrix. Small capital is it should be some kind of coefficient, right? But I'm not sure if that's a precise definition. Maybe I'll bug about it, but I just was too lazy to do it. Because technically speaking, if you think about it, even if it's just one coefficient number, right? So for number one, the A equals to 4 and B equals -7, right? Even then, technically speaking, you could say this is a matrix, 1 by 1, right? So this matrix 1 by 1. We've actually seen that on the very last question of section 1.3. Remember when we had to go through the multiplying a bunch of different matrices for that June and May sales, and what beautiful thing happens on the last question? If you times all like y, x, and matrix m together, you are ended up with a matrix dimension of 1 by 1, which happens to be the total sales, right? So technically, it is a matrix, right? So yeah, so I'm not sure if that is the best definition, but as far as we're concerned, that's good enough. But, and the reason why I have these things is just so that I know when I'm writing outside of the screen zone. Noticed those problems and I was too lazy to edit it properly or redo the video for that matter. That's, God forbid, right? So, anyways, so since one is pretty straightforward, let me try maybe, I'll just do this one, just so that we have a decent idea. So let's try 2A as an example. So that's A, B, C equals A, B, C equals B, A, C. So you're just filling in the A's and the B's so that, whatever number you get should be the same for all three, right? So let's do B and C. So B is 0, 2, 1, -4. C is 4, 1, -3, -2. And the A, which happens to be 4, 4. Really? Oh, okay, yeah, I see, okay. Let's see, that's 0, 2, 1, -4. I don't think this really matters at this point, but whatever. C is going to be, which is going to be the same thing as 2, 1, -4, and then A is going to be 4, C, 4, 1. You're starting to see why it's really a silly argument, right? Because they all have the same matrices, or it doesn't really matter. And ultimately, what coefficient does is merely change one of the matrices, right? So order really doesn't change, right? I mean, if it was like a CB or something, yeah, we have a problem. But the order times like BC, 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 same order, right? Coefficient just irrelevant. It just changes the entries a little bit, but not the orders or anything of that sort. So yeah, so that's why I didn't want to do it. But you know, since we wrote the question all the way down anyway, might as well do it, right? So the 0, -6, 6, 0, -4, 4, 16, 6. Okay, and that's going to be 1, -8, 9. Right, yep, okay, that's that. Okay, we could do this first, whatever, 8, 4, -16, 4, 1, -3, -2, 0, 2, 1, -4, 16, 4, -12, -8. Yeah, but like, you understand how silly this is becoming, right? There's really not much to prove. That's going to be -4, 6. And if you do this, -24, -16, and I can't do this, 16, and 48, right, so that's going to be 16, that's going to be 2, 3, huh? Oh yeah, they're both possible, right? Yeah, okay, so it's going to be 4, 5, 6, yeah, 64, and then that's going to be 4 and 32, 36, and it's going to be the same thing, 0, that's going to be -24, that is going to be 0, and -16, 16, and 12 times 4, I should know how to do that. Okay, so 12, 16 is 50, 64. 64, and 36. Yeah, so that's essentially all you're doing for the rest of the 2B, C, and D. So, you know, just make sure you're comfortable with the multiplication and addition and so forth. But again, you know, I wouldn't really worry about DC. That's why I'm only doing 1. To be honest, I probably shouldn't even have done 1, or 2, but whatever. And 3 and 4, again, the same thing as what we've been doing. The only difference is we have transposons, right? So we might as well. Should we bother doing it? Yeah, no, I wouldn't really bother with it. The only thing that you might want to be sure of is that if you have a coefficient, so small a or small b, whatever, right, for -7, right? If you do a transposon of that, what would it be? And a lot of people might say, well, there is no such thing, or I'm confused or whatever. Really isn't that difficult, right? Because what was the whole point of transposon again? It's just, you know, if you have I, and j, that I and j is going to just simply switch. That's all there was, right? There were some tricks for 3 by 3 or 2 by 2, but ultimately that's how, right? Now, if you have one entry, so for example, let's say it was 4, right? So that's going to be just A11. If you do transposon of that, right, A and j switches, well, that's still going to be 4. So it's not that there is no transposon. There is, technically speaking. It's just that, you know, from a numerical perspective, it's negligible, right? So that's all there is. So I wouldn't really bother worrying about this, to be honest. Let's try something a little bit more interesting, though. This is where you get to really explore the idea of inverse in matrices. So well, I'm sure most of you have done 5, so let's try 6. So that 6, and so that's going to be B equals 3, 1, 5, 2, right? So if that was the case, so we're trying to find the inverse of that. So that met, right? So if that's the case, that's gonna be, so one of the terms that I want you to get a little bit familiar with is called the determinant. What the hell is a determinant? Determinant is AB minus BC. Oh, sorry, AD minus BC. I'll write down just so that I said it correctly rather than having a stroke. AD minus BC. This is the determinant. So the whole fraction is not a determinant, technically speaking. For quiz purposes, probably wouldn't be a big deal. I would just make it, I'd probably ask something like that just to throw everyone off, but I'm a jerk, so whatever, right? So it's gonna be, and I should remember the rule. Yeah, I totally should remember the rule. So it's gonna be AD. So it's gonna be, so I think what's gonna happen is this is going to change, and this is supposed to be just flip the sign. So I should know, but I'm gonna double check. And that is gonna be just changing the sign. Yeah, fairly certain. So that's all they're gonna be. Now A, B, A, D, B, C, we should probably sub it in right away. Oh yeah, okay. So let me give you the general formula first. Sorry. A, D minus B, C. So A and D are gonna, they're gonna do the flip. But the B and C won't flip. The only thing they'll flip are signs. So yeah, so that's a general equation, and that is also in your textbook. Yeah, that's page, I'm sure you guys can find it. Page 45 is a theorem 1.4.5. So, oh, interesting thing. They haven't really talked too much about this, but technically speaking, this is not all matrices are invertible, right? So, as you can see here, the only thing where this equation cannot happen is AD minus BC becomes 0, right? Can't divide anything by 0. So I guess that's the only trick, right? So have that in mind. If AD minus BC becomes something, stop doing the inverse. It's not going to work, right? Don't waste your time flipping these. Anywho, okay, so that's that. So if we were to follow that, so that's going to be so 1 minus AD, so 6 minus 5, 1. Oh yeah, so, yeah, okay. So basically when you determine AB minus BC for the determinant, to calculate the determinant, get the A, B, C, D from the original equation position. Don't do the inverse by switching the AD and stuff like that first, and then put negative signs. And yeah, so don't use numbers from there. Use the numbers and the positions from the original matrix that was given to you, right? So still is A, B, C, D right here. I haven't done any flipping yet, right? So 1 divided by, so AD is 6 minus 5. So happy coincidence. It's going to be 1 over 1, right? Which is going to not affect any of the entries within the matrix. Anyway, so that's going to be 2, 3, negative 1, negative 5. That's all there is. This may change the number, but here 6 minus 5 is 1. 1 divided by 1 is 1. So it's just going to look like that. If it wasn't, say it was 11, then I suppose leaving it like this doesn't really make any difference. I mean, I wouldn't want, but technically you could be doing this. And maybe some of the numbers might simplify further, possibly. But the most important thing is that you remember the rule. That's really what matters. So 6 is done. Is 7 any special? It's by itself. Yeah, again, yeah. So D, again, same idea. I don't have to do any explanation, so I'll just shut myself up and then just do it, just so that we're all on the same page. So that's going to be... I'm just trivial when it comes to these things. 2 negatives, so they cancel out. I should be doing this way faster. But I did something wrong. No, I didn't. I keep thinking I have to flip the sign. Yeah, okay, no, it's not. So, okay, just double checking to make sure you can see all of this. So anyways, that's all you have to do. Nothing big, no big deal. I mean, compared to the shits we have to do in 1.2 and 1.3, not much of a hassle. Okay, so for question 15, some people were having confusion with this, but it's the same concept. So I actually did both ways. One is a little better than the other from a numerical perspective. But the common way of doing it, which is also represented on the textbook, is that you have so you have 7a and you have this 7a to the power of -1 is the -373. So what you do is you put negative exponent on both sides, right? So it was like this before, right? It was like that. And then what I did is I said I'm going to do inverse on all of them, and all of them right there, fairly, right? So if that's the case, inverse and the inverse cancels out, so you're going to have 7a. And then if you just do inverse to this matrix, then you know it's the standard drill, right? 1 over AD minus BC, and then you know A and D stays is flipped, B and D stays the same, but their sign is flipped. So if you get that, then you gotta get 7a equals 1 over 1, but there's a negative there, right? 6 minus 7, right? And then you have this function, negative will just cancel out all the negatives, and so you have this happy 2713. You gotta isolate the 7, so all you have to do is just simple divide, and then you have this answer. Pretty simple, right? Next one, still the same idea, just the number gets a little bit challenging. So if you're not good with math, maybe avoid this step. But you know, it works just the same. Some people were trying doing this. So basically, what I did was instead of just getting all the thing by putting inverse for the entire 7a to the power of -1, right? So instead of doing that, so I just actually simplified it before even doing anything. So it's going to be 1 over 7 because inverse of 7 is 1 over 7, and and inverse of a still stays the same place, and then nothing has changed because I didn't do anything to this left side of the equation. And what I did is I just moved the 7 right on the get-go. So you have a to the power -1 equals 2. These numbers look a little weird, but all I did was -3, 7, 1, -2. I just times it by 7 because I times 7 on this side to cancel out the 1 over 7. So I times 7 on the right side to be fair, right? So I have this bigger number, right? And then essentially what you're doing is the same thing, right? So a to the power -1, so do -1 and -1, right? So if you do that, then you're gonna the inverse will cancel out. The only thing is that the determinant gets a little too big for my comfort zone, but it's doable, right? Especially for a law table calculator, I think we are. Maybe not the graphic ones, but nonetheless. So you have that. Yeah, so then the same procedure, right? Maybe AD minus BC, it's just that numbers are bigger, so it just looks a little intimidating, and the usual drill with this, flipped, negative. And then it sounds a little big, but again, 1 divided by 294 minus 343, that seems like a bad number, but if you can bring it down, if you simplify it, it's just going to be 1 over -49, and you're going to have these numbers. All of them have a common factor of 7, so have that in mind, and it should be pretty easy to simplify. So I just mash these coefficient and matrix together. So everything, all the entries in the matrix will be divided by -47. So, you know, 7 times 2, 14. 7 times 7 is 49, right? So if you simplify it all up, then it actually comes out to be the same answer as this one. Okay. So pick your own poison, but you know, nothing too tricky, right? If my editing don't go as well as I hope, and usually they don't. YouTube editor is not the most elegant video editor out there, but I may have tried to get excited about using transposon to cancel this. It can work. It's just the only but there is a catch, right? So all right, I could put here. Transposon is the same thing as a transposon -1. So it does work. This does work, but this won't actually cancel anything, right? And so just be careful with playing with those things. That's all. Right. And we'll look into that more later in the other questions yet to come. So let's try 15, for example. Transposon. Oh no, 16. That's what I meant to say. 5at -1 equals so how would we go about with this, right? So again, so what you could be doing is you could be doing the t to the power of -1 is going to be the same thing as -1 transposon. Is that going to be that useful though? I don't think it would be. But so if I do the same trick, let's see if that we can do it, right? Doesn't say we can't do that. I mean, it's going to be more ugly looking, but nonetheless. So inverse and the inverse will cancel out. So it's going to be 5a t equals 2 -6 minus 5. And then it's going to be -3, 2. Like that, right? So if that's the case, then it's going to be negative. Positive, yeah. Okay, divide by 5. So 5 goes here. Let's divide by 5. So dividing by 5 as well. So that's going to be okay. So it's going to be 2 over 5 negative, 1 over 5 negative, 1 and 3 over 5. That's going to be that. So now we're going to do the transposon, which itself isn't very hard. Oh no, this is already transposed. So we have to do the reverse. Yoink, yoink. So that's that. So in order to get rid of the transpose, so if we go back to A, then this better be, so the first one, because they have the same row and same column, they shouldn't be changed at all, but the other one will flip. So it's going to be 1 over 5, negative, and then 1. And you can always reverse your step to see if that makes sense, right? So if this, and the transposition shouldn't be that, right? Well, it's true, because every time when you do transposition, any entries, they get sort of like reversed, right? So, yeah, so that will be the answer. So again, similar idea as 15, right? Just, it looks a little more intimidating because that's got transposons and your inverse will just look bigger in nature, but again, it's the same thing. Let's try 17. So 17 is going to be, I'm going to start here. I don't know why I keep going towards left. I plus 2a. Okay, so if that's the case, then yeah, again, so, use the same trick right now. It's the same idea. And then that's going to cancel out. Equals 2a equals 2. 1 over -5 minus, use that pi. 1, -2, -4. Okay. Oh wait, are we looking for I? No, we're finding A. Oh, I is the identity matrix. Okay. So yeah, exactly. So that's going to be 1 plus 2a equals 2. Oh wait, did I screw up? I did not screw up. I did not. Okay, so that's going to be negative. Really? I do not like that number. Okay. I don't know if I want to do that. Basically, what is like, do I want to multiply this now or can I do it later? I don't think I can. I have to do identity matrices. Cut. Yeah, but I guess I think this is still going to be the simpler way anyway. So let's go about with this business. Okay, so that's going to be 2a equals 2, 5 over 13, 2 over 13, 4 over 13, 1 over 13, check the minus sign of minus, cancel, cancel, cancel. Bring this matrix all the way back. 2a now will equal to 2, negative 5, 13, 4, 13, 1, 13, 2, 13, minus I, which happens to be 1, 0, 0, 1. I is just an identity matrix, right? So it's, yeah, so essentially I and j they have the same, so entries with the same row and the same column will be 1, everything else will be 0. So anyway, so that's that. And then divide the whole thing by 2. This looks insane, but let's give it a try. Okay, see, I write this, and it makes sense probably to you too, but just in case if it's a violation of some matrix laws or whatever. So that's gonna be, this is like liability issues. Like, okay, never mind. I'm just talking to myself. Okay, so that's the case. So that they're gonna be 13 over 13, just for a mental thought, right? So that's gonna be negative 1, 8 over 13. Nothing changes on this side. Then 13, dude. Yeah, so if that's the case, then that's going to be negative 12, 13, divided by 2. Are you kidding me? Divide by 2? Okay. Oh, that is not good, especially since the numbers ain't pretty. Okay, so if that's the case, then it's going to be 13 over 26, 12 over 26, 4 over 26, 12 over 26, because I'm dividing by, so essentially the reason why is because if that's the case, then a equals 1 over half, right? So I'm just multiplying, multiplying the top and the bottom, and there's nothing on the top, so that's what I'm doing. You really do not want to simplify, nor are we required to, I don't think, but whatever. 9, 13, 1, 13, can't work that way. 26 can't be divided by 4, so it's going to be 1, 2, 13, and 6, and 13. I was hoping for a more different question. This seems like a one-trick pony. 18 is going to be exactly the same, right? It's even easier because we don't even have to algebraically isolate for the a. So yeah, I'm not going to bother doing that. Okay, so that's that. Is there anything else? 18, 23. Let's try 23. This one's easy too. Like 1.4 is a lot easier than anything else. But anyways, A, B, D, C, D, B. Just because we're going to do both. Same idea. So, yeah, this is a term that you should be getting very familiar with yourself with. Commute. What does a commute mean apart from the transportation, the term, apart from the fact that we use that term for transportation? Well, what it is that it just simply means this. So, if the order doesn't matter, right? Because it doesn't matter, it doesn't really matter in the typical algebraic situations, but in linear algebra, matrices, we've already talked time after time about how, that's not necessarily the case, right? Order does matter. It's for a variety of reasons, right? Because the entries that are being times are different, and also the size dimension could be also a factor as well. But if despite all those barriers, they still manage to make it work, we say this is these are commute matrices or commutable or whatever you want to call it. So that's really what commute means. So what is it asking is if A and B, oh actually no, I didn't have to raise it. A and B are commutable, which means A, B, and BA are going to be equal. What do the values have to be? Well, let's see. So let's literally just copy and paste, if you will. A, B, C, D, 0, 0, 0, 1 is equals to 0, 1, 0, 0, A, B, C, D. Yeah. So let's just check. So they're both 0, so don't bother. 0, A stays, There goes 0. C stays. 0 times A, yeah. So that's going to be C. B is not there, so D, 0, 0. So, if they're commutable, these two have to be equal. Okay, well, let's see how it helps. So 0, this entry, row 1, column 1, should be the same as row 1, column 1 here, if they are the identical matrix. This is 0, this is some unknown C, so C must equal to 0. A and D should be equal. 0 and 0, that doesn't really help much. C equals to 0, which we already knew about. It's right there, right? So 0, 0, if you want to write that, you could. This just means you have infinite solutions, which makes sense, right? So the only thing we know is C equals 0, and A and D have to be equal. But as far as a B is concerned, B can be anything, right? So this might be this is a really simple question, but I could give you a little bit more complicated matrix and say, if you can, like, let's say there were two commutable matrices, right? Which entries matter and which entries don't? That would be a very good question. I hope the teachers don't see this, but because I have to think. But if that was the case, then you can look at this and say, oh, okay, well, C has to be 0, no matter. Oh no, C. So for this, wait, hold on a second. For this situation, I'm just wondering if this is general. Maybe this could be a general statement. I'm not confident enough to say that, but like I was actually thinking about like how, okay, A and D has to be the same, so if you look at A and D, these numbers have to be the same, and C has to be 0. As long as you do that, B, we don't care what number you put in, it's gonna work out. But that's only because we know A and B have to be commutable, right? You can't put that as a general statement, I don't think. A, B. Right, you can't make that as a general statement because, never mind, so it won't work because that assumes, so A, B, C, D is completely general, so A could substitute for anything, so that's general enough. B, however, is very specific, 0, 1, 0, 0, so A, B, that sounded really stupid. A, B, and BA are only commutable, but that assumes that B is 0, 1, 0, 0. Let's say there were B and BA are commutable again, but maybe it's not 0, 1, 0, 0. Maybe this time it's 1, 0, 0, 0. Then you're going to have a different rule. So I guess it's not specific enough to be any useful. So never mind, my bad. But nonetheless, that's all you really have to do for 23. 24 is really the same thing. Now this time they're saying, well, are A and C commutable, which is the same thing, right? Or it doesn't matter when it comes to multiplication. Let's check. A, B, C, D, A, B, C, D. And this one is 0, 0. Oh, no. We already know it's commutable. Can we just skip to... At least the matrices are simple enough so that we can cancel out a lot of things at the same that. So A, B, D. So that's going to be B, D, double 0, 0, 0. I can make that assumption quickly because here, 0, 0, right? So 0 gone. A and B. Okay, so in the situations, we can say, well, B equals 0, 0 equals 0, right? B equals 0, 0 equals 0, D equals A, and 0 equals B, which we already know. You can write it again, but it doesn't really serve the purpose. So these conditions have to happen for AC and CA to be commutable. Or other way around, since AC and CA can be commutable, B has to be 0, and A has to be D, A has to equal to D, and because 0 equals 0, I'm assuming that's because C could be anything, right? Infinite solutions. Okay, 23, 24, 31. Oh, 31 is going to be the interesting one. So, But I think the video is getting a little long, so I'm going to stop here. And next one, we will be sure to finish 31, 39, 40, and 43. The 4 questions that you really should be focusing on, because the rest are pretty easy. But anyways, I will see you in part B.